Alright, so we're going to be talking about composition of functions. Biggest thing to realize here that this is not multiplication. The notation we're going to have is we're going to get some new function, call it Harry, h of x, is a result of combining f of x and g of x. And notice that it's not f of x written next to g of x like our multiplication. This is what multiplication looked like, and this is what composition of functions look like. So biggest thing, composition is not multiplication. It's actually when we take g of x and it's inside of f of x. And so we're going to do a little substitution. So we're going to take inside to outside because we always work inside the parentheses outward. So we're going to take g of x and put it inside of f. So take g, this function, and put it in every single x that you see over here. So we're going to have negative 2 times 3 minus x squared plus 4. We're taking our 3 minus x, plugging it right in. And so order of operations here, just be very careful with our squared there. So the negative 2 is going to just hang out there for a little bit. 3 minus x is being multiplied by 3 minus x. We're squaring it. Do not distribute that squared over. It's not distributed over subtraction or addition. So negative 2 is going to be multiplied by 3 times 3 is 9. 3 times x, negative 3x. Negative x times 3 is another negative 3x. Negative x times negative x, positive x squared, plus 4. So now our negative 2 gets distributed. Negative 18. And this is a minus 6x when we combine those. So let's just add negative 2 times negative 6 is a positive 12x minus 2x squared plus 4. And so our final answer, let's just rearrange this in standard form. We put the x squared part first, and so negative 2x squared, we have a plus 12x, and we have a negative 18 and a positive 4, so that makes a negative 14. And so this is our final function. It's as if you did g of x first and then f of x, but this is just combining it into one. So we have x squared, so that's a quadratic function. And so again, there's no restriction in what we say our x's can be. And so our domain is all real numbers. So what we're going to do now is just the backwards part of that, g of f of x. We're going to take f and plug it into g because we're going backwards. And so now f, take that and plug it in for your x. So we get 3 minus what f was. Negative 2x squared plus 4. This one's going to be much easier algebraically than the last one. 3 minus a negative 2, so it really turns into plus 2x squared, and minus 4, and so we get positive 2x squared. 3 minus 4 is a negative 1. Again, we ended up with a quadratic, and so our domain was all real numbers. This next one is composition of functions, but with a number. And so we have a new f of x, and we have a new g of x. And so what we're going to do first is work inside out. G of 1 is on the inside, so we're going to find g of 1 just like we did in the last lesson. G of 1 is when you take 1 and plug it in for every x in g. So you get 1 minus 2 times 1. 1 minus 2 times 1 is just 1 minus 2, and so we get negative 1. So g of 1 is negative 1. So really, if we take our negative 1 and plug it in for g of 1, what we're looking at now is f of negative 1 is going to be our final answer. Negative 1 took the place of g of 1, like this. Instead of writing g of 1, we write negative 1 because they're equal to each other. Now we take negative 1 and we plug it in for f of x. So we have negative negative 1 squared. So negative 1 went in place of the x, and minus 1. So be very careful with these negatives because you want to do exponents before you do multiplication. And so negative 1 squared, negative 1 times negative 1 is a positive 1. One of the most common missed things in algebra. Negative 1 minus 1 is a negative 2. And so if you put 1 and first plug it into G, you get negative 1. And then you get negative 1 and you plug it into F and you get negative 2. What this notation is saying, if you had a mapping, is you have 1 that you started with and it went through function G and you got negative 1. And then it went through function F and you got negative 2. Alright, so there you have it. Composition of functions.